A software is more than just a program code. It is not just a program code. Do we get this efficient and reliable software product by following certain scientific principles? Android development software is used as a software programming paradigm. In order to reduce the size of the delivered software, always the executable form of the software is delivered to the client. Hello everyone, it is Dr. Ravi Kumar. We shall see the first unit of software engineering, that is software process. In this software process, you will come across different phases of that. That is, during the process of software product development, you will come across this phases. That is, the first one is requirements, second one is system analysis, third one is system design, fourth one is code design, fifth one is testing, sixth one is deployment, seventh one is maintenance, and eighth one is updates. These are the different phases through which the software will be progressed throughout the development of the software product. If that is the case, what is a software? A software is more than just a program code. It is not just a program code. It is not just a simple program. It is an executable code. It is an executable code which serves for the computational purpose. Suppose if you want to make use of these software products for the end user, you can make use of it to reach the requirements of that end user. That is the meaning of that. Then, software is considered to be a collection of executable programming code. What is the meaning of collection of executable programming code? When we deliver a software product to the client, we will not deliver the entire code to the user. Instead, we will give the executable form of that. That means it works on his system locally or via internet. But the only thing you need to understand here is the executable form of the software is given to the user, not the entire coding part of that is not given to him. Then, software when made for a specific requirements is called as a software product. As I told you that a software product is a process. It has to go through the process of requirements, system analysis, system design, code design, testing, deployment, maintenance, and updates. Once it is deployed, it is delivered to the client. Once it is delivered, he may come with few more updates. Then it has to be incorporated. Once it is incorporated, it is given back to him, and if there is any updates, those updates must be given to the client. That is how the process of software engineering goes in the case of software product development. Then, what is the meaning of software engineering? Software engineering is a principle that defines as to how the software product is to be developed. That means a software product can be developed by following certain principles and methods of software engineering. What is that principle? The principle begins from requirements collection. That is, gathering the requirements of a client is one of the important phases of software development life cycle, wherein you will also learn that the software product is built based upon the well-defined scientific principles and methods and procedures. That is called as a software engineering. A software engineering is a branch of This engineering that is based upon the software, that is based upon well-defined scientific principles, methods and procedures. The outcome of this software engineering is an efficient and reliable software product. I am using the word efficient and reliable. What is the meaning of efficient? Suppose if I give some values to the system, that is A is equal to 5 and B is equal to 10, and suppose the operation to be carried out is sum of these two numbers, it has to perform 15. Suppose if I give A is equal to minus 5, B is equal to 10, then it has to show that the sum of this is equal to 5, that is B minus A, that is equal to B plus A. Plus of minus is this, minus. So sum is this. So suppose similarly, A is equal to 5, B is equal to minus 10. Then it has to produce that, sum is equal to, that is A plus B, that is B plus A, minus 10 plus this. It returns minus 5. Similarly, A is equal to minus 5, B is equal to minus 10. Then it has to give the value that sum is equal to minus 15. So what is this happening here? Sum is the functionality written over there. But please keep this in your mind. When the values of A and B both are positive, the value returned was 15. When one of the values is negative and the other one is positive, it was able to return the value which is 5. Then when one of the values is negative and the other one is positive and the other one is negative, it was returned minus 5. Again, it is a sum of these two numbers. Again, when the value of this is both are negative, it has returned minus. Again, it is a sum of this result. Result is a sum of this. So what is that operation it is doing? Sum operation. It has to be efficient, generalized. It has to work for all the inputs, possible type of input given by the user. Then we say that the program written by the programmer is an efficient software. Now, what is the meaning of reliable? The reliable word means it has to work properly in the environment, or environment in the sense it is an operating system which is installed in your system. Whether the operating system which has been installed in your system may be a Windows operating system or Linux operating system, or it may be another Android operating system or any other operating system. It has to work properly. Then it is called as a reliable software. So the outcome of software engineering is an efficient and reliable software product. How do we get this efficient and reliable software product? By following certain scientific principles, methods and procedures of software engineering. We will be able to obtain an efficient and reliable software product. That is why we call it as a software engineering is a branch of engineering that is able to produce a well-defined, efficient and reliable software product by following the principles of well-defined scientific and methodologies and procedures. Now, if you look at this evolution, software evolution, what is the meaning of evolution? Human evolution. Incarnation, you will say that. What is the meaning of incarnation? In the next incarnation, what would be the life of you? What would be the life of us in the previous incarnation? That is the word meaning you will come across, right? Evolution, evolve. The same thing comes to the picture of software development, software product development. Here, developing the software product using software engineering principles and methods or procedures is referred to as evolution. It is not just a procedure. It is a principle we need to follow when we start developing a software product. We have to follow certain procedures, methodologies. Suppose if I take up the method of waterfall model, I have a certain procedures which needs to be followed according to that requirement, according to that procedure, according to the principle of that software development lifecycle model of waterfall model. So that is how the process of developing a software product using the software engineering principles and methods are called as software evolution. Then that includes initial developments like requirements collection, gathering the requirements from the client, and the maintenance and updates till the desired software product is developed which satisfies the expected requirements. As I have already told you that when a client approaches the software developer, he has to keep in mind what is the requirement of that client and how those requirements can be met by following certain principles, methods, and procedures of software engineering so that an efficient and reliable software could be delivered to the client. That has to be the main intention of software developer. In order to develop an efficient and reliable software, it must include the process right from the requirements collection till the maintenance and updates are given to the client. Then it includes this one. Software analysis evolution includes the software release. Once it is released into the market, that is, once it is delivered to the client, the client may come up with few changes to it. That is called as change requested. Once it is requested, it has to be incorporated. That is done with the help of system update. This is the first step, second step, third step. Any updates are there, the changes incorporated. That is called system update. Then the release planning. In the fourth phase, you will see that the planning which is released, then impact analysis. This is the fifth step. Here, this is called as software evolution process. Next, you will see that evolution starts from the requirement gathering process till the updates are given to the client. That is, when the software is delivered to the client, he may come with few more changes which needs to be incorporated into the software. Then the changes must be incorporated and delivered to the client. That is called as an important updates or changes requested by the client is incorporated and delivered. That is called as collecting the feedback at the early stage of the software product development. You please listen to it carefully here. Create a prototype. I did not tell the word here because this is very, very important in case of software evolution. Involves software prototype development at the initial stage. What is a prototype model? A prototype model is not an actual working model. It is a model that simulates the original software, so that the prototype model is delivered to the client works with it. When he wants to incorporate few changes to it, come to the software developer with few feedbacks. So this is what the requirements which needs to be met in this. So once it is collected, he will incorporate directly into that original software, so that the changes requested by the client is reflected in the original software. So that is what the software developers are following in today's trend. The user suggests changes on which several consecutive updates and maintenance keeps on changing too. That is what? He will come up with few changes, and those changes must be incorporated into the existing software. This process changes to the original software. That is, it gets reflected in the original software till the desired software is accomplished. That is, till the requirement of the client is met. Next, you will learn about software paradigms. What is the meaning of paradigms? It is not paradigms, it is paradigms. What is the meaning of software paradigm? In this case, you will come across the programming paradigm. Second, you will come across software design paradigm. Then you will come across software development paradigm. What is the meaning of programming paradigm? In case of this programming paradigm, you will use some of the technologies like Android. Android development software is used as a software programming paradigm. What is the principle? What is the procedure you need to follow when you work out with the Android application development software? There are certain principles, right? What is the requirement of a client and how those requirements must be met in the form of programming. Once it is completed, you will come across the software design, that is, right from the requirements collection, how it has to be designed. It has to be planned accordingly, according to the requirements of a client, right? That is called as a software design. So, programming is a part of software design. Software design is a part of software development. So, this is called as the process of software paradigms. The same thing you will see here. Software paradigm refers to the methods and steps which are taken while designing the software. Designing in the sense, suppose if you have some data needs to flow through different modules. Suppose if there are 4 modules in a project, each of these modules generates a certain output, certain data. When the data is given to the first module, it processes the data and produces some information. This information is given to the second module. The second module takes this information and further produces few more information, adds a few more information to it and produces one more information. So this process, evolution, that is the process of moving the data or information from one module to another module, is called as a software designing process that has to be designed and represented in the form of a pictorial representation. For example, if you have come across the sequence diagram, you will understand, or a use case diagram, or a class diagram, or an object-oriented diagram, you will see that how the data flows from one module to another module. That has to be represented in the form of a pictorial representation. That is called as a software designing process. That is this software designing process. There are many methods proposed and are in work today, but we need to see where in the software engineering these paradigms stand. Yes, these can be combined into various categories through each of them is contained in another. Software programming paradigm is a subset of this software paradigm, design paradigm, which is in turn is a subset of software development paradigm. The same thing is here. Now, next, this paradigm is known as a software engineering paradigm. Now, in this case, it consists of the first one, requirements engineering, second one, software design, third one, programming. Next, you will also see that design, maintenance and programming also includes coding, testing and integration. So these are called as software design paradigms. That is, the very first one is requirements gathering, software design. Third one is programming, that is the actual development. Fourth one is design, maintenance and programming. Then you will come across coding, testing and integration. So this paradigm involves the very first thing, that is requirements gathering or collection. That is collecting the information, what is required for the client. It has to be written in the form of a documentation. It has to be written. Next, you have software design. Here, the documentation is done here. During the process of this, a pictorial representation is written. Is drawn. Then the programming, what has to be the programming language and which programming language supports certain criterias and packages so that the requirements of the client may be easily met. All those things are written here. That is technologies suitable for software development. Here the design, again the class diagram or object diagram, all those things, diagrams are written. Maintenance, once it is developed, it is for maintenance. That is documentation, design, development and all these things. Then programming, here you will use the different types of languages like C, C++, Java, .NET, Python, so on like that. Once the coding is completed, you will go for testing, then integration of all these into, that is different modules are combined together to form a single entity or a single big project. This is called as module M1, module M2, module M3, module M4. All these M1, M2, M3, M4 are combined together to form one single software product. Software product. Now, the same thing, design, maintenance, programming, testing, coding, integration, all these are certain types of software paradigms. Then you have need of software engineering. What is the need of software engineering and where it is actually needed? It is needed when you want to develop a large softwares. For example, the software of ATM machines which you are using every day or few of the days. When you want to withdraw money or when you want to deposit some money, you will go to the ATMs and you will do the transactions. What is that on-screen information refers to? That is again a large software product which is developed for the purpose of meeting the requirements of everyday banking solutions. So similarly, it has to be scalable. What is the meaning of scalable? It must be able to reuse and extendable. It is not the meaning of developing again from the scratch. Scalable means it has to be in a position to extend the existing functionalities to meet the requirements of a client. That is called as a scalability or scalable. Then cost. Cost is also another important criteria wherein you will see that what is the total estimation for developing that particular software product. That is also an important factor. Then it has to be dynamic in nature. What is the meaning of dynamic in nature? When you have a software product which needs to be delivered to the client, and important updates must be incorporated successfully into that. Suppose once you deliver the software product to the client, he may come up with few more changes. This is what the changes needed in that existing system. Then it must be incorporated. That is, new important updates must be successfully incorporated into the existing solutions. That is called as a dynamic in nature. Next, quality management. The quality management is possible, that is software quality management is possible when you follow certain principles of software engineering, methods of software engineering, and procedures of software engineering, so that the quality of the software product can be maintained and delivered to a client. Then characteristic of a good software product, that is, first one is operational, second one is transitional, and third one is maintenance. Under operational, you will come across different types of characteristics. Please keep this in your mind. OTM. OTM. O stands for operational. T stands for transitional. M stands for maintenance. So under operational, you will come across different types of characteristics. That is this one. It has to fit the budget. That is under operational. You will come across the first one, that is budget required to develop the software. Second one, usability. Third one, efficiency. Let me write down all these characteristics and then go on explaining that. Fourth one, correctness. Fifth one, functionality. Sixth one, dependability. Seventh one, security. Eighth one, safety. All these are certain characteristics of good characteristics of operational characteristic of a software product. What is the meaning of budget? Suppose if I want to develop a software product, I need to employ few staffs into that, the technical staffs into that, a supporting staff for a technical staff. They have to be paid with that certain amount. So ultimately at the time of delivery of software product, what is the cost spent on those resources? All those things are calculated. So that is called as a budget. Then usability, whether it is usable at the client or at the user end, that is also very important. Then efficiency, whether it is working for all the types of possible test cases of input given to the system. That is an efficient software. As I have already discussed with you, for all possible type of inputs, it has to work properly. That is called as an efficient software, a generalized software. Then correctness, it has to work properly even when the inputs are given, because if there is any error in the inputs given to the system, it has to say that this is the exception. This is what the mistake done by the user. That has to be rectified by the user at the time of entering the data into the system. That is called as a correctness. Functionality is that it has to function properly when the inputs are given to the system. Dependability, it depends on one module to another module, that is called as a dependability. Security is another issue. When the software product is in use, it has to be secured. That means it must not be able to be accessible to other people to use it. That is the purpose of using the security. Safety, when using the software, it must be used safely without any problems with it. That is called as an operational characteristic. Then the second one is transitional. What is the meaning of transitional? That is, it has to be portable, interoperability, reusability, and adaptability. That is, under transitional, we have these characteristics. Under transitional good characteristics, portable, it has to be a portable software. That is, second one, interoperability. Third one, reusability. Fourth one, adaptability. Here in this case of transitional, the word transitional indicates from one to other. Suppose if the software is working on Android operating system, it has to work even on Windows operating system. That is called as an interoperability. Interoperability, that is, it has to operate well on Windows operating system as well. It has to work even on Android operating system, even on Unix operating system, even on Linux operating system. That is called as an interoperability. This interoperability characteristic is very, very important when you deliver a software to the client. Then that is portable. Portable means the size of the software product must be very less. In order to reduce the size of the delivered software, always the executable form of the software is delivered to the client, not the actual software is delivered. That is the meaning of portability. Then usability, that means reusability. That means if there is any changes which needs to be incorporated at the later time, those changes can be incorporated easily with the existing module. Instead of developing again from the scratch, we can make use of the existing module and start giving the updates to the existing product. Suppose I will give one example to you. If you purchase any mobile phones, the mobile phones are installed with few Android operating systems. Once when the software update is given, the existing software is updated and the new updates are incorporated into it. That means the reusable condition is applied there. That is called as a reusability. Then adaptability. It has to work on different environments, whether it may be a Windows operating system environment, or it may be a Linux operating system environment, or it may be an Android operating system environment, or it may be a Linux operating system environment. It has to adapt well for the environment where it is installed. That is also another important characteristics of transitional. First one is operational, second one is transitional, third one is maintenance. That is this maintenance. Under maintenance, you will come across modularity. That is the first one. Second one, maintainability. Under third one, flexibility, scalability. All these are under maintenance. Yes. What is the meaning of modularity? That means, as I have already told you at the introduction class of software engineering, suppose if you have a big problem to be solved in a software product. Then the big problem is divided into smaller sub-problems, that is called as a modules, individual modules, and a solution to these smaller individual modules, sub-individual modules, gives a solution to the big problem of software product. That is called as a modularity. Then we have maintainability. What is the meaning of maintainability? Once it is given to the client, once it is delivered to the client may come up with few more changes, or he may not come up with few more changes. He may request you to tell what has to be the input for that particular form. Then in that application, this must be the input given to the application form. That is, if you go to the Gmail server and to the Gmail account, you have to enter the username and password in the appropriate fields. If you enter the password in place of username and username in place of password, you will not be able to log into the system. So you have to guide the clients as to how they can manage the systems according to the requirements specified by the user. So according to that, he has to give the information. That is called as a maintainability. Then flexibility and scalability. Flexibility means, in the sense, it has to be able to change the requirements. That is, when it is installed in different operating system, it has to work properly. That is called as flexibility, as well as interoperability. What is the meaning of scalability? As I have already told you, that the scalability, in the sense, when we want to incorporate new changes or updates into the existing system, it must be capable, or it must be scalable enough to change into the new updates given to the software product, existing software product. That is called as a scalability. Now, in short, software engineering is a branch of computer science which uses a well-defined engineering concepts which requires an efficient, durable, scalable, in-budget and on-time software products. Please keep this in your mind: efficient, durable, scalable, in-budget and on-time software product. Thank you very much. Thank you all. If you have any questions with respect to the topics I discussed today in software engineering, you may ask me the questions in the live sessions. Thank you very much. Thank you all.